Okay, so now that we have our tangent function, or excuse me, our identities all squared away, let's do the first thing, which is to find some exact values. So the strategy here will be to rewrite our angles in terms of our common angles, our nice special ones. So in degree mode, those are any of our quadrantals, 30 degrees, 45 degrees, and 60 degrees. And of course, this would be pi over 6, pi over 4, and pi over 3 respectively. All right, so that's the challenge, and then once we get them as a sum or a difference, we can invoke the right trig identity and then find our exact values using our unit circle or our memory if you've committed some of these things to memory, which I hope you have. And so we'll begin this journey 75, thinking about what two things add up to 75. All right, there's a lot of ways to do it, but one of the ways that I can think of it is to think of this as 30 degrees, plus 45 degrees. All right, that's a plus sign there. So invoking the addition sign of a sum, that's the sine of 30 degrees, the cosine of 45 degrees, and then we're going to be adding the cosine of 45 degrees and the sine of, 30 degrees and 45 degrees respectively. All right, so there's basically our sum of a sine. The sine of 30, when we look at our of 30 degrees, this is 1/2. The cosine of 45 is the square root of 2 over 2. The cosine of 30, that's a 30 there, is the square root of 3 over 2. And we're going to be multiplying that by the square root of 2 over 2. So we get square root of 2 over 4 plus square root of 6 over 4. So putting that all together, we get the square root of 2 plus the square root of 6 all over 4. And there would basically be our exact answer for the sine of 75. All right, so the tangent of 195 degrees, well, again, thinking in terms of quadrant, this is all the way in quadrant number 4, and quadrant number 3. So we're expecting a nice positive value. But let's see, 95, I'm thinking if we subtract 45 from that, yep, so we get the tangent of 150 degrees plus 45 degrees is a way to break up 195. So now we invoke the identity. So this is the tangent of 150 plus the tangent of 45 all over 1 minus the tangent of 150 and the tangent of 45. Okay, so the good news is the tangent of 45 is 1, right? Tangent to 150, how about I go do a right triangle if we just forgot? But in terms of a right triangle, 150 has a 30-degree reference. So this would be negative square roots of 3, 1, and 2. So the tangent would be 1 over negative square roots of 3. And rationalizing that denominator, we get negative square roots of 3 over 3. So this would be negative square roots of 3 plus 1. And on the bottom, we have 1 minus negative square roots of 3 over 3. And so this was basically, how about I write this as 1 minus the square root of 3 over 3 all over 1 plus the square root of 3 over 3. All right, so that's basically where we're at. And now what we have to do is some simplification. So let me give myself a little bit more room. I'm going to use the idea, let's clear the fractions. So I'll do that by multiplying both top and bottom by 3, right? Because the LCD is 3. So when I do my distribution, I end up with 3 minus the square root of 3 upstairs and 3 plus the square root of 3 downstairs. And now the trick is to rationalize that denominator. So we do that by multiplying by a conjugate. Upstairs we have to literally FOIL it out. So 3 times 3 is 9, minus 3 square roots of 3, minus 3 square roots of 3. A negative times a negative is a positive. Square roots of 3 times square roots of 3 is 3. On the bottom we have the difference of squares. So 3 times 3 is 9, plus minus is minus, square root of 3 is 3. So when we're all done here, it looks like we have 12 minus 6 square roots of 3 all over 6. And if we do some dividing out, we have 2 minus the square root of 3. So after all that work, the tangent of 195 its exact value is 2 minus the square root of 3. So we've got that exact value all ironed out, and maybe a little bit of review of our right triangle to kind of help me and assist me get that done. Alright, so what about sine of pi over 12? Well, in the previous video we found that if we take pi over 3 and subtract pi over 4, right, this is 4 pi over 12 minus 3 pi over 12, which gives us pi over 12. So this we can rewrite as sine of pi over 3 minus the sine, minus pi over 4. So we basically have the sign of a difference. So invoking that formula, that identity, this would be the sine of the first angle, the cosine of the second, minus the cosine of the first, and the sine of the second. Alright, and then using our memory, or our right triangles, or a unit circle, right, the sine of 60 degrees, well, that's basically the square root of 3 over 2. Alright, and the cosine of 45 degrees is square root of 2 over 2, minus the cosine of 60 degrees is a half, and that's the square root of 2 over 2. So we end up with the square root of 6 over 4 minus the square root of 2 over 4. And so this, its exact value, is negative square root of 6 minus the square root of 2 all over 4. And so there would be our exact value of the sine of pi over 12 using our difference identity. Tangent of 7 pi over 12, this is one we haven't seen, but how about we just use what we had here? We were subtracting, but if I would add, right, we get 4 pi over 12 plus 3 pi over 12, which gives us 7 pi over 12. So we're basically looking at the tangent of pi over 3 plus pi over 4. And so we're basically using that same identity up here. So we have the tangent of pi over 3 plus the tangent of pi over 4, and then 1 minus the tangent of pi over 3 times the tangent of pi over 4. And so again, what's nice about the tangent of pi over 4, this is 1. The tangent of pi over 3, well, this is a 60 degree, right? And so in terms of 60 degree, let me draw another really quick reference here. For 60 degrees, this is the square root of 3 and 1 and 2. All right, and so for 60 degrees, y over x is the square root of 3. So we have the square root of 3 plus 1, 1 minus the square root of 3, right? Because that's the square root of 3 and that's 1. Okay, so again, there's where we're at, but we have to rationalize this denominator. So let me give myself a little bit more room here. So we have the square root of 3 plus 1 all over 1 minus the square root of 3. So to rationalize that denominator, I will multiply by the conjugate. Upstairs we have a big FOIL, so we have the square root of 3 plus 1 plus the square root of 3. Downstairs we have the difference of squares, which turns into 1 minus 3. And so we have 4 plus 2 square roots of 3 all over negative 2. And then simplifying, we end up with negative 2 minus the square root of 3. So this is negative 2 minus the square root of 3. And there's our exact value for the tangent of 7 pi over 12. So again, the idea is to take our angle, rewrite it as a sum or a difference, and then as soon as I do that, we can use our identity in a sign or a difference, and then make that all go to work. Okay? So, and then we're invoking our unit circle or our right triangles to kind of remember and recall some of those exact values. And then it's just a process of simplifying, especially for that tangent. We already are dealing with a fraction, and so the chances are of us having a radical down to the denominator are very high. Let me do the next two in a new video, since we're almost 10 minutes into this, and we'll break that down in a video coming soon. See you guys in a moment.